so satisfying.
No.
Linear measurement, okay? Hey, let's go to the sideboard. Fun Sock Friday, okay? We are in the bottom category, SWBA. Someone remind me what that stands for. Students will be able to. The T is silent. Students will be able to measure linear segment section 1.2, okay? Section 1.2. Okay. Hey, I know this had like a... And oops, okay? For this, okay?
It's oop, not
Oh.
oop. And oop.
Last few must bring down after, okay?
Oh my
And
goodness.
oop, okay? On this. I know it printed like really off to the side and cut a few things off. I'm sorry about that. I didn't realize that until it already printed. I'm like, oh no, okay? And I fixed it afterwards, but it already printed them all. And so I wasn't going to go through and print a ton more of these and kill a bunch of trees, okay?
Yeah, that's
So,
good.
we're going to make do, okay? A postulate, we also call it an axiom. Okay, it's also called an axiom, okay? It's a postulate or an axiom. Now, a postulate, we'll call it a postulate more often than not, is a rule that is accepted without proof. You guys need to write in the word proof as well, because it doesn't have that on your sheet, okay? A rule that is accepted without proof. So you guys need to write without proof there. So kind of like our undefined terms from last class, we have our postulates, and we just accept those to be what they are. We just say, oh, that's the thing now, okay? We're just going to accept that as a ground rule, okay? Kind of like the in science class, okay? How like matter can't be created or destroyed, okay? Kind of just accept that, okay? I know. Kind of just accept that to be a fact, okay? And then we build other things off of that, okay? That's the way a lot of math is too, especially in geometry. We accept certain things as facts, and we build certain things off of that. So postulates are our facts. Now theorems, these are a rule that can be proven, okay? So those theorems come from that, okay? So if I were to draw this out here, don't draw this part that I'm going to do, okay? Don't draw this part, just watch, just take it and take in my massive art skills. Actually, it's going to be a botch, but that's okay. So we have like our postulates here at the bottom, okay? We have like our postulates here at the bottom, and then we have like, along with like our undefined terms, okay, that we learned, like the points, the points, the lines, and the planes, okay? Then on top of that, we have our theorems, and we have defined terms, okay? So it's like a building block, okay? The postulates and the undefined terms are our base, and from that we build up these theorems and defined terms. We have to have a place to start with. So the postulate and our undefined terms were our place to start. We just accept those as true. Our theorems are things that we can now prove to be true because of the postulates and undefined terms we have, okay? We're able to define our other terms now because we have those postulates and undefined terms. And because we have this base, we're now able to build all of these other things on top of it, okay? Believe it or not, there's actually different kinds of geometry than the one we're going to be learning this year, which is the most common type of geometry worldwide. But there are other types where these postulates and undefined terms are actually different. And thus, what comes after it is different as well. Anyway, moving back. Just wanted to take a sideshow to explain that, okay? So absolute value, okay? We know what absolute value is. It's distance that a given point is from 0 on a number line, okay? It's the distance a given point is from 0 on a number line. And it is always positive, okay? You guys might need to write that below because you don't have the blank on the right of that because it dropped off, okay? So absolute value is how far a number is from 0, okay? That's why it's always positive. Because even -5 is how far from 0? 5 from 0, so that's why it's positive, okay? So -5 is 5 from 0, so that's why the absolute value of it is positive 5. Sure.
I already did that.
Yeah, if you guys want to abbreviate stuff, what I do, that's fine. Okay. As long as you can understand. Yeah, these notes are for you. These are for you. Whatever best helps you guys is what I want you to do with these notes. Okay, I want you to fill them out with me, but whatever best helps y'all, I want you to do. Okay. Okay. I don't know. I don't grade the notes. These are for you. Okay. Measuring segment length. Yeah, well, I can grade these notes. That'd be terrible. Okay. Measuring segment length. Okay. This is our distance. This is our distance, okay? So the distance between any two points would be x. This is a sub 2, okay? Think of it kind of like when you had slope, okay? You have slope. slope, okay? Like y2 minus y1, okay? It's not saying 2 times y, it's saying the second y and the second, and the first y. Here it's saying the second x and the first x. You subtract them and you take the absolute value, okay? Now actually, it won't matter which one you subtract from the other, okay? We'll talk about that here, okay? Actually, I'll talk about that right now, okay? You don't have to write this part down. But if I do 5 minus 3 and take the absolute value, what is 5 minus 3?
2.
Yeah, what is the absolute value of 2? 2, okay? Now let's say I switch these around. I switch x1 and x2 around, okay? 3 minus 5 and the absolute value of that. What is 3 minus 5? Negative 2. But what's the absolute value of negative 2? Positive 2. So is the distance still the same?
Yes.
Yeah, so it doesn't matter really which one of these you have in which order because we're taking the absolute value at the end. So even though subtracting the order typically matters, when we're doing the absolute value of it right after, it won't end up mattering, okay? It's like saying if I go from here to Bellevue, or if I go from Bellevue to here, does that change how far I go? No, it's still the same distance either way, okay? It doesn't matter where you're starting from or where you're going, it's still the same distance. It's not like, oh, to go to Bellevue, it's negative 20 miles, or negative 15 miles, or whatever. But to go from Bellevue here, it's positive. That'd be weird, okay? You have negative distance. All right, over here, A and B, the capital A and the capital B, those are the name of the points. So the name of points. Okay, we know we use capital letters to talk about the name of the points. Okay, whereas the x1 and x2 are going to be the coordinates of the points, like x, y style. Okay, coordinates of the points. Okay, questions on that so far? Okay, we're doing great. Okay.
Wait. Okay. Yo, I was thinking
Find the distance between the 2 points. Find the distance between point T and point W. If T is at negative 4 and W is at 10. Okay? How do we go about that? Well, we do the same thing we did with the measuring segment length. Absolute value of x2 minus x1. So what is the what is the coordinate of T? Negative 4. Okay? Negative 4. I put in parentheses when I substitute in. What's the coordinate of W? 10 minus 10. Okay? Well, what is negative 4 minus 10? What is the absolute value of negative 14?
14.
So the distance between the 2 points is 14 units. We aren't told what kind of units, it's just 14 though. Now, could you also go on here and count?
Yeah.
Sure. Could we have done 10 minus negative 4? Yes. We can switch around the points, remember? Okay. I want you guys to do B, okay? BW. You guys have to write that down. You can write it like right below it or to the side or underneath the number line somewhere. I want you guys to do B, okay? Justin, you got it? Yeah. Now we just hold on. And I do.
I want him to become this little girl from home. Like, I just need to have. Or Blue Devil Mania. Or that too. I will.
Rowan's like weird to me. Like,
Rowan is uncultured, that's why. Rowan is a grandma.
Am I, or do I want him to respect himself?
You're just a grandma. You're the grandma.
These chairs are very hard.
sorry about that.
School is a death trap, not.
Okay. What was our length of VW? 2. Okay, you get there, you can do 8 minus 10, 10 minus 8. Either way, you take the absolute value, right? It is whoop, whoop, 2 units away, okay? Question of yes. Yeah, you can just count. Whoop, whoop. That works, okay?
Our teacher called them baby butchies.
Baby butt these?
Yeah.
You do okay. Oh, kind of funny. Okay, questions? Let's go right below this. Congruent segments. What does it mean to be congruent? Congruent segments are segments that are equal in length. So if two segments have the same length, we say they are congruent. Okay, and we have this symbol for them. You got a symbol for them? Yours just says Simbo. The L dropped off. Symbol though. Simbo. Okay. And what it is, it's like an equal sign with a tilde.
Ew.
A tilde, not a Matilda.
Okay. Now, even though in Spanish you have a tilde, you pronounce it differently. Okay. We're not gonna say it's equal instead of equal because of the tilde on it. We say it's congruent. It's a whole new thing in math. Okay. So it's similar to being equal, but it's when it's equal in length, the segments themselves are congruent. Okay, so from the number line we had above, can anyone see two congruent segments? Okay, from this number line we had, can anyone see two congruent segments? Taylor, what are you thinking? ST and T, what's the length of ST? 3. What's the length of TU?
3.
So yeah, the lengths are the same, so they're congruent. So what we can do now is we will say that segment ST is congruent to segment TU. Okay, we'll say that segment ST is congruent to segment TU. Just like you say two things are equal, we can now say two things are congruent. Okay, once again, these segments themselves are congruent because their measures are equal. Okay, the measures are congruent, the segments are equal. Segments are congruent, the measures are equal. Okay. Okay, they're equal length. Because numbers can be equal, but segments cannot. No, segments can be congruent though. Okay. Example 3 here, okay? Name all congruent segments seen in the figure below. So that you see in the figure below. So it cuts out the word that you and the rest of below. Kind of looks like bellow. Hello. Beto, okay. So, hint, labeling. What the hint means is these tick marks are marks that we use to denote two things being congruent. We use those tick marks to denote that two things are congruent. So, if this has one line and this has one line, that means FG is congruent to CD, okay? So that means segment FG is going to be congruent to segment CD because they both have one tick mark, okay? So following that logic, can somebody give me another two segments that are congruent? Graydon.
D, E, and F.
Okay, D, E, and F, E. Why do you say that, Graydon?
They both have 3 ticks.
They both have 3 tick marks, okay? Now, do we think one with 3 tick marks is going to be congruent to one with 1 tick mark? No, they have to have the matching number of tick marks, okay? Could we have wrote FE is congruent to DE? Could we have switched those order? Heck yeah, you can, okay? Peyton.
So like, would it be A is congruent to B or AG is congruent to
Okay, AG is congruent to segment BC. So you wouldn't just do the point because points don't have a length. You would have to do the segment. That's a great question. Okay.
I wrote it out. Oh my god.
And you could, but geometry like shorten things out. Symbols. Okay. So we named all congruent segments in this figure below. Okay, because we said that they have to have the same number of tick marks. Okay. Now, if I asked for something that wasn't congruent, we could say that segment AG is not congruent. And now, you know how we have not equal with a line through it? Okay, we have not congruent, same thing. Okay? Segment AG is not congruent to segment, we could say ED, for example. That's a 2 tick mark and a 3 tick mark.
These symbols are too extravagant.
Yes.
Control the AC.
No, I don't know.
See, it's bad. It's like,
It's cold.
It makes sense.
Bring a jacket.
Open
No,
it.
no, no.
It's in the winter.
Oh, wait.
It's like
Bring a jacket.
It's like warm outside.
Okay, that's something. Okay. So, talking about distance versus segment, okay? Cut off the word segment for you guys there. Talking about distance versus segment here, okay? The distance, that'd be saying the measure, little m for measure, the measure of segment AG is equal to the measure of segment BC, which is equal to some number. Bless you, let's write down after you forget. Okay. We're saying the measure of segment AG is equal to the measure of segment BC, and those are both equal to some number. Because the measure of that, we can actually find the number for that. Like we found the measure of those segments, the length of the segments, okay? We We use that little m for measure before it, okay? But with the actual segment, you'd say segment AG is congruent to segment BC, okay? The segments are not equal, they are congruent. The measures, though, are equal because numbers can be equal.
Oh, that's not. Where am I ever gonna use this in the group?
I'll answer that question another day, okay, purely because of time for today. But I do have an answer for it, okay? It's not what you like.
Wait, is it like because you're doing another job as a teacher, like that kind of answer?
Oh, did we get out of here?
Okay, we do, okay? But we ended up taking one, which is okay, I'm not upset about it, on checking our homework, which is fine, because that's a long assignment to check. We're learning how to check, we're learning how to ask questions in here. So it's just a process. So I think as we get more in the swing of things, it's gonna go a little bit quicker, okay?
Also, every question, 5 8.
Yes,
We just have one page
Okay.
left though, so we can do it.
yes, flip the page, right?
1 2.
Back it.
Oh.
So, here, we're supposed to plot these points. Plot J, K, L, and M. So practicing plotting points here, okay? Plotting J. Negative 3 comma 4 is what it says. So where would I take this point J and where would I put it?
Left,
3.
Left
Up.
3,
4.
up 4.
You're welcome.
The first number is the x coordinate, right? The left to right. The second number is the y coordinate, up and down, okay? Where would I plot point K?
Right 2, up 4.
From the origin, very good. 2 to the right, 4 up. What about L?
Right.
Boom, okay? And what about M?
Right 1, down
Right 1, down 2, okay? Then determine whether segment JK and segment LM are congruent. Okay, so we need to put segment JK in there
Whoa. I don't like that.
and segment LM in.
Do I have to explain it 'cause I
No. Okay. How can we know if they're congruent? What would have to be true? Their measures would have to be the
Same.
same. So what is the measure of JK? Can we count?
5.
Yeah, it's 1. Let's make some baby butt cheeks. 1, 2, 3, 4, 5. It is 5. Okay. What is the measure of LM? 1, 2, 3, 4, 5. Baby butt cheeks stay. So we know the measure of segment JK is 5. I'm going to write this down. The measure of segment LM is equal to 5. So does that mean their measures are equal?
Yes.
So what can we know from that then?
Congruent.
So segment JK is in fact congruent to segment LM.
Can I do measure JK equals 5 equals LM? What?
The top of those socks are hard stuff. It's like an
Oh my
extra
goodness,
thing.
they are hard. Oh, I'm please.
Questions?
No.
Okay, hey, could we have counted this? Could we have counted this out if this line was slanted though? If the line was like this, could we have just counted straight and go like, oh, 1, 2, 3? No. We'll have to do something else we'll learn next Tuber Type Tuesday on that, okay? No. Okay. We're gonna learn about segment addition, okay? Adding segments, okay? So what this is gonna be is it's saying, hey, if I take segment AB, which is part of this whole segment, and I add it to segment BC, which is the other part, do I get the whole thing? Yeah. Okay? Like saying, if I take the distance from here to high V, and from high V to Beaver Lake, no, what? Isn't Beaver Lake down there?
Yeah.
Okay, if I take the distance from here to high V, and from high V to Bellevue,
No.
if I add them up, do I get the whole distance from here to Bellevue?
I know.
Wait.
Yes.
Yes.
Yes,
It's
you
not
would.
equal. Bellevue is a lot further.
No. If I get the distance from here to high V and add it to the distance from high V to Bellevue,
You get from Bellevue to.
then I get the distance from Bellevue to here.
Okay.
Okay? So if I take part of the segment and I add it to another part of the segment, do I end up getting the whole segment? Yeah, that's all segment addition is saying, okay? This is a postulate, okay? It's saying if you add part of it plus part of it, added to
Why
plus,
do I feel like I'm in fifth grade?
right? If If you add part plus part, you get the whole thing.
Part to the part.
That's what it's saying.
No way.
Let's practice this. So if AB, segment AB has a length of 13, segment BC has a length of 27, what would our length of AC be? 40. How'd you get that? You add them. Okay? If here to here is 13, and here to here is 27, that means the whole thing has to be added together. So the measure of segment AC, so I want us to write our answer for length. The measure of segment AC is equal to 40.
Woohoo!
Questions? Okay. You guys ready for the classic math teacher saying, let's make it more complicated. Okay. It doesn't get a ton more complicated, just a little bit, okay? So, find the length of GH. Wait a second. This time, are we given the whole or a part? Whole and a part. What are we looking for this time, though? A part. Okay? How can we set up the problem? Kevin? Okay, you can do 36 minus 21 is equal to this unknown value. What can we call this unknown value?
A.
A, X, any variable, GH. Okay? Another way we can think of this is normally it'd be part plus part, right? Part plus part equals whole.
So you do whole minus part equals part.
So if we subtract a part from both sides, then we get part is equal to the whole thing minus a part. So we have the whole thing, 36, minus a part will equal our other part, A. So what does A end up equaling? So the measure of segment GH is 15. Questions on that one?
What?
Let's work on number 7. Let's set up number 7 together, but I'll have you solve it on your own, okay? Find the value of X and segment JK. This is between J and K if K is between J and L. K is between J and L. So what are we going to draw here? Pictures are helpful. We're going to draw a line segment.
Why do you use so much equations?
What's the endpoint? What are the endpoints?
J and L.
J and L. How do we know that?
Because it says K is between them.
K is between them, right? Okay, so where does it matter where I put K in here, really?
No.
Somewhere between them, right? So you know K is between it. Okay, so we're supposed to find the value of X and JK if K is between J and L. Hey, look, we're told some measures, okay? And these aren't even cut off for us. So we're told the measure of JK is equal to 3x minus 4. What am I going to do with that information?
Use it.
Label it, okay? So I'm going to label it. I like to label my stuff this way when I do this, okay? I just put 3x minus 4 above JK, and I like to do these little, like, almost like bracket type things, okay? To tell me, hey, I'm talking here to here. I think it's pretty descriptive of what we're doing, okay? And then K to L, we're told is 5x plus 8. So I'm going to put that in there, 5x plus 8. If you have a different way that you like to label and it works for you, go ahead and do that, okay? Now we're told, what about JL? 104, that's a whole thing. I think it's pretty clear from my picture what the different measurements are, okay? I think that's pretty clear from my picture, okay? I want you guys to try writing down the problem of what we would do, okay? I want you guys to try writing the problem of how we would solve this. Okay, I want you guys to try writing how we would solve this, okay? So go ahead and write down what mathematical equation, what algebraic equation, okay? Algebra is used in geometry all the time that you can do here to solve for x.
Oh, wait.
Let's just write it right now. I guess if you're done, go ahead and start solving. Okay, does anyone have it want to share what would be a patent?
Like you said it equal to like y and subtract
I don't know what you're telling me.
so like 3x minus 4 and then set it equal to a variable.
Okay, not quite. Okay, Braden.
3x minus 4 plus 5x plus 8 equals 40.
Great, explain that.
So, we're just adding two parts. So we just have to put those in the addition and they have to equal one point.
Okay. So it's the same thing we did up here. We add the two parts to get the whole. We're adding the two parts. Part of it's 3x minus 4. The other part of it's 5x plus 8. And we said if we add these two parts, what do we get? The whole thing. Bless you, must rain down in Africa, lest we forget. We're taking part plus part equals whole, and we're just replacing part and part in the whole. It's like we're substituting them back in like an algebra equation. Questions on how we get this set up? Okay. Let's work on solving this one together. So what would be our first step? Combine like terms. So what would I combine?
3x, 5x,
Become,
8x,
and then what else can I combine?
-4 and 8.
Become,
You got 4 and 8. That's not great.
okay? How would I get x by itself? What would I do first?
4.
Subtract 4 from both sides. 4 minus 4 is 0. 8x is now equal to 136. How do I get x by itself now? Divide by 8, okay? You don't know off the top of your head, we can, it's understandable if you don't know 136 divided by 8, okay? Does 8 go into 1? No. Does 8 go into 13? Yes, once. Later, 5, 56. It goes into 56 7 times. Okay, we found x. Are we done once we found x?
Yeah.
We can find jk. How could you find jk? Plug it back in, right? We can plug it back in, okay? So we can take 3 times 17 minus 4 and we get jk. 3 times 17 ends up being 51. I'll spoil that for you, okay? Minus 4. So measure of jk now, you can now say is 51 minus 4, aka 47. I know I went a little bit quickly on that last one. Are there any questions on that? I know I went a little bit quickly on that last one. Are there any questions on that? Okay. I'm being mean, Mr. Teacher, and giving homework over the weekend at the end of class, okay? Once again, I think once we get into our rhythm a bit more, and we get a little more used to how the process is going, I think we'll end up avoiding this more often than not, which is good. Otherwise, I hope you guys have a great weekend. If you have questions on this, do you have to wait until class, or can you come in beforehand? You can come in before. You guys can come in on Monday before after school. You guys can come in Tuesday before school. Okay? There's no. You guys can feel free to come in during that. Okay? I'm here to help you guys. So as long as I'm in here, I'm ready to help you. Okay?